Okay, so let's start the session. So I want to start by comparing our city with our body system. So the infrastructure of the transport system is like the bones. It support our body, and you can think of the parks as the lung of the city, and then the workforce like the muscles, to keep our body moving, right? So these are the people who drive the economy. The lungs, the parks are place where we have recreation, also clean the air, but importantly, the road is like the blood vessels in the city. Okay, so what happens when you have a blockage in the blood vessels? Right? So that means that the whole system your body doesn't flow properly. Like whether you have when you have a stroke or something like that. Because the transport systems, transport goods and people, just like our blood vessels carries the oxygen and to the rest of the body, and the freeways is like the main arteries. So they are the major infrastructure to move people and goods. And then you have the little ones like going to your residential streets and so forth. Okay, so if you think like that, the cities and the transport system, we need to have our whole system running. So every part has to be moving properly. If you have a blockage in one part, then you have a problem. So if you have a clot in your artery, so it's just a bit like your congested network. So things doesn't flow very well. Okay. Because it doesn't flow very well, it means that we talk about pollutions in the questionnaires. There's emissions because you just stop starting, and people cannot lost productivity because instead of working, they're spending time in congestion. There's higher cost of travel. Right? So if we have an efficient system, the city doesn't function well. That's why we need to have a very efficient transport system. So severely congested city is not a good thing. Just think about our body system. So if you want to be healthy, every part has to be working properly. So because this subject is about ITS, and then the question is, what is actually ITS? So a very simple definition would be ITS is the use of technologies in transport operations and planning, and we apply it in vehicles or to infrastructure for all transport modes. Basically, it is just the use of technology to address all the transport problems, whether it's solving congestion problems, safety issues, or pollution problems. The use of technology. So that's what ITS is about. So what you hear a lot of time is about, if you are a transport operator, just imagine that you work for the transport department. Some of the main issues or objectives that you try to deal with are always the same. Okay. First is about improving efficiency. So you want to make sure that there's no congestion, or there's no severe congestion, I should say. You want to make sure that all the traffic signals are running properly. They are real time. Okay, so there's no time loss in the delay. There's about safety. So you might want to make sure that the road is safe, so for people to travel. Okay, so efficiency. You want to improve efficiency. You want to increase safety, and then you want to reduce environmental impact. So you want to reduce pollution. And that comes in different forms, either greener transport, getting more people to use public transport, or you have a better signal timing so that there's less delay at the intersection, or you use a different type of fuel, so moving from fossil fuel to electric vehicles. Right? Also, people start to talk about the quality of experience. So it's not just about making it efficient, safe, and sustainable. We also talk about quality of experience. Quality of experience here means that often comes in the form of reliability. So, for example, if it takes you 30 minutes to get from your home to PolyU, every day it's about 28 minutes to 32 minutes. That's okay. You can plan your time quite well. So if it's one day it's 30 minutes, the next day is 45 minutes, and the other day is 25 minutes, you can't really plan your time, right? So that's not very reliable. So you don't have a very good experience. You can't plan your time, especially for those who are moving trucks who are moving goods. Sometimes they have a time window for them to work. So they say, okay, you have to be at the depot between 8 to 8:30. That's the time window that they will be served. So if they are late, they get penalized. So they need to. So the travel time itself is not as important as the reliability. So they need to be sure that they can get there on time, right? Rather than if it takes them extra 30 minutes, that's not a problem. So the quality of experience is important. So these are in fact, the top three things are always the same: about efficiency, about safety, and about sustainability. Okay, so from the operations point of view. So in the questionnaire, we talk about traffic congestion. So that was the one topic that came up all the time, that Hong Kong congestion is very bad. So let's take a look at some perspective. This is from TomTom Travel Index. Again, when you see figures like that, I think these are indicative. It's not absolute. Okay, just give you some idea about where it ranks. So you can see Mexico, Bangkok, Jakarta. Those are like top 3 cities in the world. And Hong Kong ranked number 44 in the world and 22nd in Asia. So it's not the worst place in the world according to this survey. Okay. And there are quite a few Chinese cities, like in Beijing and a few others. Shenzhen is also there. So the Hong Kong congestion level, yes, it is bad, but relative to the world, it's not that bad. Doesn't mean it's good. I'm just showing you as a relativity. One part we didn't talk about earlier was about population. Congestion is caused because we all want to travel, right? So if there's hardly anybody who wants to in the city, then there will be not many travel trips made, and so the demand for travel is less, and then there'll be less issue. But Hong Kong is it's a very very densely populated cities, so that's something that's a factor. So if you look at it from the global sense, from the world, the populations is projected to increase from 7 billion to 9.5 billion by the year 2050. Okay, so this is the growth, but most of the growth will come from most of the growth will actually come from Africa, right? From 16% to so that's where the growth will be. But population itself is not necessarily a problem, right? Because if the let me put it this way. Why do you think there's a congestion? Apart from why do you think there is a congestion? Is it because what causes the congestion? Apart from a lot of people, what do you think causes congestion? So lack of road capacity, too many cars. What other? So let's suppose you have the road capacity of 2,000 vehicles. Okay. Now let's suppose you have 20,000 cars. So what caused that congestion? So you have the capacity of 2,000 vehicles per hour, and you have 20,000 cars. There must be some parameters that make it congested. Okay. So if you have 20,000 vehicles, it's not really a problem. If you spread over the day, you have a lot of capacity. So if you have even if you have 24 hours a day, even if we talk about 20 hours a day, so that's a lot of capacity. There's 40,000 vehicles you can fit, right? And you have 20,000 cars. It's never a problem. The problem is everybody wants to go at the same time. Not only that, you want to go at the same place. Okay. So that leads to the next point, which is about not just about population. Actually, Hong Kong is a lot of countries in Asia. The population is going down in the future because the birth rate is low. Sorry, I'll talk about this later. So it's about people wanting to go to the same place at the same time, right? So that's why you have this congestion problem. And in Hong Kong is a fantastic example because it's very dense and there are very few places you can go, right? I mean, it's every part is very congested. So I'll touch on that later. But also in terms of transport, we saw the projection that population is increasing, but not necessarily in a lot of Asian countries. So for example, in Japan, you already see that the population is already on the decline. Korea is the same. You saw the previous slides. Hong Kong is projecting downwards as well. So a lot of these countries, the population is likely going down. They are going down because of a lot of the aging population. The leading ones would be in Japan. You can start to see them, the issues that they have. So this is the population for 2020 in Hong Kong, the age group. So this is 0 to 4, 5 to 9, and then 85 at the end. Right? So you can see in 2020 the bound is still about 25 to 60. That graph. But if you look every 5 years, you can see that the graph is shifting to the right. Right? So what you see is that by around this time, you can see that there are quite a lot of very old people. So this is another 50 years. You can see that if we don't do anything different, then this is the projected population in Hong Kong. Right? There are a lot of old people. So in terms of transport, there are challenges. So how do you cater for these people? So they may not be able to, for example, some of them might not be able to drive. Some of them may need special type of buses. Maybe the minibus may not be the best way for them to travel. So those are issues that needs to be considered in terms of transport. So the working age population is shrinking because you can see that the graph, the 85 and above are increasing. Numbers of pensioners, of course, is increasing because they are not working. So the support ratio is different. So workers to pensioners is in the decline. So more people have to work to support more. Fewer workers supporting many more pensioners. This issue. Of course, because of the healthcare and so forth, we have a higher life expectancy. I think Hong Kong is one of the highest life expectancy in the world. We also have very low fertility rate despite that. So the point about this is that for those people who are driving, at what age should they stop driving? Because technically they should not be driving forever. But if autonomous vehicles comes and help them, that's a positive. What's the impact of this aging population on transport services? So we talk about old people. So maybe in terms of the buses, the bus flow must be lower so that they can get in. So these are things that you need to think about. This way technology can help. So I talk about providing low flow public transport, providing ramps if they're on the wheelchairs. They need a ramp to access the public transport. There's something which I found quite interesting. In Hong Kong, there's not many people on wheelchairs using public transport. Is that right? Why is that? Because for example, in Australia, you can see a lot of people on wheelchairs, and they use public transport. In the buses, there's buses or train. The conductor will take out a ramp for them to get in and out of the buses, but I don't seem to see many or any in Hong Kong. It's not popular. I mean, they use other form of transport. Is that what happened? Service.
But while using public transport, we need to walk or something.
Is it allowed to bring your wheelchair into the buses? Yeah. Okay. So just not common. Okay. The other issue is about urbanization. So you find that more and more people are moving from the rural area to the urban area. So there's a concentration. So we talk about the concentration problem. So this is one of the very big problem about transport issues, is that in 2014 there were about 54%. So we are past that point where there are more people living in the rural area than in the more people living in the urban area than the rural area. And the projection is that we get 66% of the people who live in the city. So that means that more people moving from the rural area to the urban area. So that put a strain onto the transport system, right? And if the urban population is growing, the urban population is growing so rapidly. So that's a challenge for us, right? How do we cope? How do we move so many people in such a small space? So that's the challenge. So you can see that this is the urban population, this is the rural population. So we have crossed that point, right? And the projection is that more and more people are going to move from rural to the urban. I suppose because of the job opportunities, education, and so forth. So and all the infrastructure is there to support them, right? But that causes people to come into the city, and so when we have more people coming into the city in a very short space, also we talk about people traveling to the same place at the same time, so that's only going to get worse. Right? So the question is, how do we design our city better? How do we manage our our transport system better to cater for this people? I'll show this already. So this is just to show the mega cities. So you can see that the mega cities over 10 million. We have about 28, and then of those large cities about 43. So altogether maybe about 70 cities in the large to mega cities. By 2030 we get about 104. So that's actually growing very rapidly. So the cities are getting bigger, and then there are more of those cities. So that's the concern that we have. In terms of urbanization, you probably know that for the large cities, cities with more than 500,000 inhabitants. So Hong Kong, Singapore, Macau, they're the top 3 cities in terms of density. In terms of people living in the urban area, basically everybody is living in the urban area. So I mentioned about this already, about the cities are the hub of economic and social power. So everybody, because jobs is there, everybody moves there. And then city expansion also use up land where otherwise it can be used for food production. So if everybody's coming to the city, you're using up the agricultural land as well. Some of the issues would be the built-out areas. I mean, you have lots of areas being built out, so there's a low runoff. That means that water cannot get out. You know, so if you seal the whole area with concrete, when it rains, there's no way for the water to flow. And of course, it accounts for very high energy and water usage. I'm just wondering how many of you are aware of this issue about the built-up areas for urban built-up areas. Do you know the problem I'm mentioning about? So, in the city, just imagine because Hong Kong is a great example, because we built the city which is so dense, when the rain comes, the water has to go somewhere else. Yes? If you have rain. And if you don't have concrete, it goes to the soil. Right? So if you seal the road, the water has no place to run. Correct? Because you have rainfall, the water comes down, it has to go somewhere. So you can either go, normally if you don't have those concrete, the water comes down, goes to the ground takes it and it goes quite much deeper, and it goes to the rivers and then goes to the ocean. Yeah? So when you have a very heavy rain in a very built-up cities, there's no place for the water to go down, so it has to be drained somewhere else. So that's actually a very big issue, because it will cause flooding because if the water cannot get out as quickly as possible, then you get flooding in the city. Okay, so that's why one of the very big issue about. So when it's flooding, that means your transport network is flooded. All right. So I'm not familiar with Hong Kong. I'm not sure how that's managed, because I'm relatively. But do you know in Tokyo, for example, that when it rains, in the past it floods the city, and when it floods the city, it causes a huge economic damage at a very high economic cost to the city. And do you know what's the solution to Tokyo? So if you do go to Tokyo, and you get a chance, and when it's not in the rainy season, you can actually visit the place. So what happened in Tokyo is that when it rains, in the past, when the rain is heavy, the city gets flooded, the transport system shuts down. Because we talk about the transport is a very important part of the city. The transport system shut down, the city shuts down. Okay, so in Tokyo they have this underground structure. So literally just beside, there's some points along the road, the water flows under the city. So the water, because it's concrete, so the water cannot go down. There's no ground anymore, right? So there's a structure where there's an overflow structure. It goes underground in the city. So it's like a huge city under Tokyo, where they store the water. So they temporarily store the water when it rains, and until the rain is over, because you cannot pump the water to the river because the river is full too, right? So you need a place to store the water. So they store the water under the city, and then when the rivers subsides, it pumps the water back to the river. Okay, so huge infrastructures. If you Google it, you probably find one of the 7 wonders of the modern world. So it's a very huge cost to that. So urbanization is not just about transport; it's everything. It's about how do we have everything being built out? How do you manage those water flow as well? Okay, so that's the reason why I mentioned that it is related in that sense that with urbanization, although rainfall has no impact, but when it rains, it floods the road. The road is completely not usable. Okay, the land area. So transport. So in Hong Kong, the good thing about in Hong Kong is that a lot of the lands are reserved still. Well, I'm not sure it's a good thing or bad thing. The good thing is that it will not be developed. So if you like hiking, it's fantastic. But of course, when the land are not used, that means that the house price is going to be very expensive. So that's the downside. But the positive side is that a large part of the land is still reserved. But of the total urban areas, 25% area of total urban areas, so 24% of the areas are actually built up in Hong Kong. And then transport, I think, takes up 5% of that land. So transport takes up quite a part of that. And then if you look at the built-up area, so that's equivalent to, this is built-up area only, so 20% of the built-up area is used up by transport. So the challenges is that population is increasing. It's more the urban population is increasing rather than because everybody is moving to the urban area, so they put a lot of pressure onto the transport system. Then the question is how will our built infrastructure cope, because everybody comes to the city. And also we have a large population, so we need to find a way to feed the 9 billion people. Climate change is also an issue that we need to tackle. Okay. So for any questions? Before I move to the second. So I touched on about safety because so this is the figure in Hong Kong, the casualties from 1950 to 2017. The red colors are seriously injured. The blue ones are the fatalities, and then the green one is slightly injured. So you can see that every year in Hong Kong, I would say probably about 600 people are either injured, seriously injured, or killed. So that's a lot of people. That's about 5 double-decker bus full of people, killed, injured, or seriously killed. And we have, close to about 100 fatalities in Hong Kong per year. So that's a lot of people, died due to road traffic. So that's something obviously we need to think about, how to make our roads safer, either through design, through some enforcement of the law. One of the things you probably read a lot these days is about smart cities. So everybody talk about smart cities, smart transport, smart mobility, smart grid, energy grid, and so forth. So in Hong Kong, there is also a blueprint that was released in December, I think it's December, end of 2017. So the Hong Kong government is putting a lot of invest a lot of money into making Hong Kong a smart city. So the question is about what is smart city? So one of the definitions is about smart city is the use of data and technology, to create efficiency, to improve sustainability, to create economic development, and enhance quality of life, living and working together. So this is what you get from this Hong Kong smart city blueprint. So the smart Hong Kong is about embracing innovation and technology to build a strong economy, enhance quality of living, and make Hong Kong a well-known smart cities. So how many people have read about this smart city in Hong Kong? No? Okay. So this was released, as I said, end of 2017, and this is what the Hong Kong government. So you should read a bit about that. Okay, you can find it on the website. So we talk about smart cities because, or smart cities or smart transport or whatever, because we have the availability of data, because there are lots of sensors, and then we have the technology for that, right? Because we talk about smart government, smart health. Basically, it's about data and technology, and how do you use the two together to make things better. So the challenge for future cities is that we want to design a denser city, because there are more and more people moving from rural area to the urban area. So we want to be more dense city, but and hopefully less reliance on private vehicles. We touched on that earlier, because if everybody drive their cars, then there'll be the road will be much more congested. So we definitely need to rely on public transport as the backbone of the transport system. And we want to make parks more available. In terms of the smart city, we want to make sure that we're consuming less energy in the buildings. We want to shift from private to public transport. We talk about that in this discussion, right? We want to reduce emissions. We want to make the city less congested and hopefully safer as well. And the use of renewable energies like solar systems, solar energy whenever we can, consume less energy in the system through the lightings and so forth, through better management of the lift, and use less energy, better water management. So water management, what I was very interested to find out when I came to Hong Kong was that the grey water, so the water that you use for the toilet is not fresh water, right? In Hong Kong, so that's an interesting thing. I didn't realize that. So there's one form of kind of water management. So this is Hong Kong's blueprint. I think you can read about that. You can read about that in the blueprint itself. So it covers these 6 components about smart living, smart economy, smart people, smart government, smart environment, and then smart mobility. So this is more of what we are looking at. If you look at the So we covered we talked about the challenges already in Hong Kong. I'm going to skip the Internet of Things, and I want to show you a video.
cities also give us a lot of challenges, especially the architecture, because most of them face a growing population. Not only is the population growing, but it's aging. And people continue to have aspirations for better quality of life. And as the cities grow, we will have to develop more infrastructure and services for them, and we have to make sure that these services work. And with climate change, we have to encourage people to use less energy so that we reduce carbon emissions. So cities seek solutions to address these challenges. How can we deal with them? Well, many cities are starting to adopt smart technology to improve our environment and our daily living. But what is smart technology? Everybody talks about being smart. Well, in very simple form, it is really harnessing Infocom technology, the Internet of Things, and harnessing the power of data, getting insights from data, to actually develop smart applications that make the day-to-day living for us comfortable. It has been projected that by 2025, we will have at least 88 smart cities in the world. What about Singapore? Well, the Prime Minister has said that our vision is for Singapore to be a smart nation, a nation where people live meaningful and fulfilled lives, enabled seamlessly by technology, offering exciting opportunities for all. Note that it's really about people and not about just the technology. But are we ready to be smart? Well, I think we're pretty much on the journey. We are quite wired up. 90% of our homes have broadband, and we will bring fiber to every home. And Singapore has one of the highest smartphone penetration rates in the world, at about 85%. So we are on the journey. But what is a smart nation? I just like to illustrate with an example of HDB town, a public housing town close to my heart. And I call it the Heartlands. Why is it the Heartlands? Because it houses 83% of the population, and many of you and I live in HDB towns, in villa flats. So what is a smart town? The smart town really functions like the human body. With all the buildings in there where activities take place, like the muscles in our body. We have greenery and parks, like our lungs, that help to cleanse the air for us, give us oxygen to breathe. And we have all the roads, just like veins and arteries in our bodies, that move the traffic, people and goods. And you know our body has the 5 senses, and the senses send to our brain. It senses what happens in the environment, and tells our brain how to get the body to adapt, whether it's hot or it's cold. So if you add a sensor layer onto a town, it collects data. And insights from this data can help the town continue to learn and adapt. And from this, we can develop smart applications for day-to-day living. As an architect planner, actually I plan and build many of the towns that we live in. And I would very much like to build a smart town that's livable, efficient, sustainable, and safe for you. We are going to look at smart in 4 areas: smart planning, smart environment, smart estate services, and smart living. What is smart planning? As an architect planner, I love this part because it helps me to design a better living environment for you. Now, what is smart planning? Basically, the first thing I do is to collect all the data about town, buildings, the roads, the parks, and I put it in this computer. And I'll also collect a lot of information about energy use and waste, for example. And with this information, I can develop a 3-dimensional map of Singapore in the computer. Now, what do I do with this information? Well, I can do a lot. I can do a computer model that simulates the wind flows through the town. In the tropics, we love the wind. We're not in Chicago. Now, if you look at this diagram, the colors that are yellow and orange means that wind flows are pretty good. The ones in blue means it's a little bit, it doesn't move so much. So when we did the first cut of Punggol Eco Town, this was the pattern of the wind flow. And then we adjusted the buildings, moved parts around, playgrounds and my childcare center, I like to put them in the shade so that the children can be out and play. The computer can also tell you the solar irradiance count, how much sun actually falls on the surfaces of the town and on the buildings. And why is this useful? Well, it helps me to decide, for example, when there's moderate sunshine, I could put the roof gardens there. And when there's a lot of sunshine, that's where I put my solar panels. We talk about solar panels. And it is very effective. All this information helps the architect to design the town, not only aesthetically, but also to ensure that it is functional. So this is a waterfront town, quite nice. You can start applying for it. Now, we can add a layout sensors to the town, right? The layout sensors that tells you about humidity, heat, wind flow, and all this data that I collect can go back into the computer systems to validate the assumptions and make it more accurate. But more importantly, can be used in many ways. For example, in my neighborhood center, I have these huge fans. Now, I hope that these fans can be triggered when I collect data on, when I monitor the humidity of the heat. They will be triggered when it hits a certain threshold level. But that is a Greenfield site. What about old towns? So welcome to Yuhua, Jurong and Old Estate. What we did a couple of years ago is to try to introduce a lot of sustainability to the business team. This has been really greener, which means more cycling, more solar panels, more clean energy. We put in rainwater harvesting systems. But can I make it even smarter so that they're more effective? So for example, we have put a lot of solar panels on hundreds of buildings on HDB blocks. You may not see it because you didn't climb up to the roof. Now, we put in sensors to all the solar panels and we track the energy that is collected. And we know immediately when a panel is not working because it will not be collecting energy and we can fix it. But you know that such data collected can do many things. It can even tell you the weather condition. For example, if many of the solar panels are not collecting a lot of energy, it might mean that over that town it is cloudy or it is actually raining. So it's a proxy to the meteorological station. Another service that we see a lot in town, estate service, we are very familiar with is lighting along the corridor. Now, how many of you walk into a toilet and it suddenly switches on and you get a shock? Dark to light, right? Well, smart sensors allow a person to walk along the corridor. It can even predict where you're going and then the lighting level picks up. And when you're past it, the lighting level dims again and you save energy. And the data collected is useful because if along that corridor after 11 p.m. every night, very few people actually walk there, the system is smart enough to learn the pattern and to reduce the brightness of the light and save energy. Another estate service we're all very familiar with is the lift. We have 24,000 lifts in HDB towns and we monitor it every day. Now when you're sleeping at night, you may not know this, but we move the lifts when you're sleeping. Alright, there's no ghost, we move it. The reason being that we're testing it to make sure it works when you take the lift the next day, right? Now, of course, when the lift breaks down, we'll get a signal and have to fix it. But you know, with the new sensor, maybe you can even monitor the vibration and heat generation from the lift, and it can even predict a potential failure before it even happens, so that we can go and fix it first. So that's wonderful, right? Now this is a map of Singapore. If you look closely, you think there are a lot of ants running around. Now this little movements, actually, this is real time. take another bus or change a route. Alright, so such information and data is important. Now next, I talk about smart cities. By 2030, we will double the people who are
I think we just stop that. There are a few more slides in the that I have listed, so you can in the handout you can see. So any reaction to the TED talk? Any comments? No? So you can see she mentioned about the data being collected, how we can make better decisions, predictive, using some predictive tools. She talks about doing some modeling. In transport too, I'm not sure you have covered in your class about transport modeling. Do you use? Okay, in transport, whether it's in planning or in the traffic operations, there are simulation tools that you can use to simulate different conditions so that you find the optimal solution to what you want to meet the objective, right? So there are tools like that. So and she mentioned about the taxis running around, or if you are Google, then you would have to Google the data of people using the Google app. They know the speed of people traveling, so you know how the whole city is functioning. Right? So that's those data are very useful for day-to-day operations and also for planning. So that's the. I think this is what smart city is about. It's about the data and then the technology and how can we use this to make the city more livable, more efficient, more sustainable, and safer. Okay. So if you don't have any questions, I'll go to next week's lecture, because for those who came in a bit late, because we have 13 weeks of lectures, but we have 2 weeks of holiday. So instead of having a replacement class, so today we will not have no tutorials, and I will catch up with the class as much as we can, so that we don't have a replacement. So we do not need a replacement class. Okay. So I'm going to start a part of week 2 lectures, probably half an hour-ish. Okay, so think about this as a week 2. So in this week we want to week 2 we'll be talking about data sources and data processing. And just want to summarize what we talked about today. We talk about the transport challenges, with increasing in urbanization, aging populations, and so forth. So these are the challenges that we have, because more people in one place, how do we move them efficiently? The different needs of the aging population. We talk about the goals of transport system is about efficiency, safety, and sustainability. These are the key things that you see people talk about. So in terms of the data, we are looking at, we want to try to explain after this lecture, you will explain why we need to collect data. Why. So you heard even in the videos, you talk about collecting data. So why do we need to collect data? And then, what type of data do we need to collect? Right, so why we need to collect the data, and then what type of data do we need? And then how do we collect the data? And also, how's the data being used, right? So these are the things that we try to. By the time we finish the lectures, we should be able to answer this: why we need to collect the data, what sort of data do we need, how we can collect them, and then how do we use them. I have prepared the next one. I think this will be the last questionnaire. This is about why do we collect data? So maybe you can explain. And I have, I think it's the last one. Okay, I have some simple. So if you put log in, I just want to get some views about, from a transport management point of view. Just imagine if you want to manage a transport system. So why do we collect data? Why do we collect data? So you heard in the video too, she talks about a lot of data. You can use this data for that. So why do we, I think she covers, the minister covers some part about the data collection too. So why do we collect data? What do we use the data for? In terms of transport management. Planning? Somebody said that? Good. Planning and management, analysis. Control, very good. The next one. I'll come back to this, because there are two other questions I want to. I'll change my mind. Let's stick to this. So I think I'm very pleased with the response, because we talk about, I think the first one we talk about planning and management. So if we want to manage anything, or we want to plan something, if we do not know what's happening, we cannot manage the system, right? So you can say, okay, well, I would like to make my system to be more efficient. So if you do not know how it is performing now, there's no way you can actually make it efficient, because you don't know where you stand, right? So that's why you need the data. But also, if you know where you stand, you say, okay, I'm going to make my system better. I'm going to get it to this level. But if you don't collect the data, you don't know whether you have reached that level or not, whether you have exceeded the level or below the level. So those you need as well. So for planning, for management, for signal coordination, I think a few response there. Signal coordination, optimize signals, optimize travel time, signal coordination, the same thing. So if you need to know what sort of demand it is, where the vehicles are, then you can actually coordinate them. So the answers are all very, very good. To construct a model, yes. If you don't have the data, you cannot construct a model. Because when you have a model, then you can do forecasting. Okay? So they're related that way. You need accurate data. Better intercooperation. Who wrote this and can you tell me what it means? Better intercooperation. Can you explain it? it's very. I like the idea, but can you explain to me? So with the data, so we talk about people can switch mode, people can maybe wait for another buses. What is needed for this intercooperation? How do we make it work? Intercooperation. So how do we make it work?
Behind the signal, when the car goes to this pole and this next pole, the signal will give the green signal to the bus. Like this,
Okay.
and if you change from LPR or bus, and then if you can do something like this, then the bus will come in the right car.
Okay. So you touch on maybe 2 points. One could be giving priority to a bus, for example, or giving priority to emergency vehicles. So that means that the emergency vehicles need to collaborate with transport department, for example. Yeah. Or if you talk about MTR versus the bus, so that means that the two needs to share the information. Okay. So the key word here is about data sharing, right? So do you think data are freely exchanged in Hong Kong? Okay. Why not?
Because the bus don't share the.
Yes, but why not? What's the problem, do you think? Why don't they share the data? She made a very good point, right? So to make it efficient, you need to collaborate. Right? You collect the data, and if you share them, you can actually make the system much better. Right? So, for example, emergency vehicles going through light, you can provide green lights to emergency vehicles. Give priorities to buses. So that means that we need to exchange those information. The people controlling the signals and whichever the vehicles, or between different public transport modes. So the data needs to be exchanged. The question I asked her was that, why are we changing the data? It says no. Why not? Okay. Okay. So they want to maximize their profit, right? So do you think there's anything we can do to change that? Do you think there's a solution for that? By the company, okay. Okay. So it's actually a very difficult point for the transport department. They want the data, but they couldn't get the data. So if there is a solution, they will have already implemented. It's not so easy, right? Of course, obviously, if you buy the company, buy the bus and run it publicly, of course, that's one way. But it's very complicated. But you touch on you provide a very good good point about data. What do we want to measure? What do we want to measure? Because we don't want to use it for signal coordination or for planning, that kind of stuff. But so now this is what we want to do, or managing improve the connectivity between different modes. What do we want to measure? Peak time transport mode. So you want to know when is the peak time? Traffic flow. Okay. guess this one is the use of each mode. Pick out capacity. Okay. Transport pattern. Good. Real-time location, occupancy of the buses, I suppose. Speed, flow. Yeah. Vehicle types. Okay, so if we know some, let's say we combine the two. We know the demand and we know the capacity, right? And we have congestion. What do we? First of all, in terms of what we want to measure, I think it's good. So we want to measure traffic flow, traffic volume. From that we can actually look at the capacity. We can look at OD, which is very hard. Somebody wrote OD. Yeah, this is very difficult. We look at the performance in terms of speed, where people are, occupancy, so again, it can be related to demand, right? So if we know the demand and the capacity, and we have congestion, what do you think we can do? What do you think we can do with that? You know the demand, and then you know the capacity. Do more infrastructure. Okay. When do we stop building? Because there are a few possible situations where sometimes you don't have enough capacity, so you want to build more infrastructure, you want to increase the capacity, right? And sometimes there's a limit to how much you can expand, because there's also a cost involved, there's a space involved, so there are many factors involved. So it's not always possible to build the capacity. In fact, don't forget, when we talk about building capacity, we are building capacity for the peak only. Right? For example, at night there's nobody using it. Okay? So we cannot say that there's not enough capacity. It's about, we talk about people coming in at the same time and all that kind of stuff, right? So it's not quite. For some places, yes, but maybe the Cross Harbour Tunnel is always congested, so that's one exception, right? But most of the places at night there's enough capacity. But obviously, who wants to travel at night, right? So there's the issue with that. So it's not just about, okay, well, it's congested at 8 o'clock in the morning, I need more capacity, because sometimes when you overbuild, then it's underutilized in other time. So there's a bit of a balancing that you need. Okay, so I'm trying to say that the balance is not so. It's not just okay. We have a demand, we have a capacity issues. We build the capacity. Sometimes it's about you can reduce the capacity. You can reduce it's a demand supply problem, right? So sometimes you can reduce the demand, or you can spread the demand. So this is. Okay. The next one, I just want to know. It's actually more like a show of hands about the technologies. I want to know how much you know about the technology only. So loop detectors. Do you know much about that? Do you have good knowledge, no knowledge? You never heard of it before? Or you have intermediate knowledge? basic knowledge. Okay. The same thing for the next question. I just want to know about Bluetooth and Wi-Fi. Do you know anything about that? For data collection. Okay, last question, I think. So some have GPS, okay. So people with no knowledge of GPS, is it because you don't know what it is, or is it because you don't know how it works? People with no knowledge of GPS, is it because you don't know anything about it? Because GPS is, if you have a smartphone, you have a GPS. So definitely you cannot not know what GPS is. Or you might not know how it works. Okay? But we'll cover a little bit about that. Actually, on this topic about GPS, so who likes to know more about GPS? Because I can get somebody to come and talk to you. I mean, a real expert in GPS, a colleague to talk about this. So who likes to know a lot more about GPS, or just the basic about GPS? No? Nobody wants to know? Okay. Then you're going to get nothing. Okay. Okay, this may be new for somebody. We're going to cover this in the class, so I can do that quite well. This one, the interesting thing about this is somebody has no knowledge of loop detectors. I thought it's one of the most basic thing. Okay, so we're going to talk about the detectors. Okay, now. All right, so we've done the board. So basically, it's that if you cannot measure, you can't manage it. Right? So collect it, because if you cannot measure what you're trying to do, you can try to manage. You can't manage it. This is as simple as that. So meaning that if you wouldn't know if your target or goal is reached unless you define and monitor it. So if you say that I want to reduce the delay at an intersection from 20 seconds to 10 seconds on average, you need to measure it, whether you have achieved the 10 seconds or not. If you don't measure it, you don't know whether you have achieved that. But you also set a target, because you said, okay, I want to reduce delay by half, from 20 to 10 seconds, and then you need to monitor it to see whether you reach that goal. Okay. So if you haven't reached that goal, then you do make other further changes, further optimization. So in terms of the transport system architecture, first of all, we have the sensors to collect the data, like the loop detectors, for example. And then you have a control algorithm. So if we talk about a signal control or signal coordination, you go through an algorithms and then you put it into the signals. You implement those signal timings into the signals. It becomes an actuator, and then the vehicles will move according to the control system. And then because it's moving, and then the sensors pick up the new data, right? So it's a continuous system like that. So the census is required to collect the data for the control algorithms. Okay? So this is the kind of basic structure. So that's why we need the census to provide the input for the control. And once you have the control, it works out what sort of things needs to be done in terms of signal control. It will be the timings, signal timings, and then you implement the traffic signals. The vehicles gets the green lights, move around. Those who are on the red stopped. And then because of that, those movements, the sensors pick up new data. Okay. So loop detectors, it picks up. So this is an example. So that loop detectors pick up the traffic volume. If we talk about traffic signals, and then calculates the signal timings. The loop detector doesn't do that. The algorithm does that. Then it implements the traffic signals. Right? And then the driver's response, which is here, and then it goes back again. What do we measure? So remember, in transport, we talk about the metrics, about efficiency, safety, and sustainability. These are the three main ones. And then sometimes we talk about quality of service. So if we want to measure, if we want to look at efficiency, so we tend to look at the speed, I think that higher speed is better. The amount of volume that we can, it carries, or the throughputs, the number of vehicles that we can push through, the capacity of intersections or a section, the amount of queuing, amount of delay. So this is kind of efficiency. The throughput here and the volume also is a very interesting thing. In a transport system, should we be counting the number of cars, or should we be counting the number of people that we carry? Because the concept is different. So should we be counting number of people, or should we be counting number of cars? Because if we are trying to maximize the number of vehicles going through, then you're optimizing number of vehicles. If you're optimizing number of people, then the prioritization is different, right? So you probably prioritize. Let's say for example, in an extreme case, you have one street which is only private vehicles, the other street which is only public transport. Right? So if you count number of volumes, so you might have 5 buses goes through, and then 5 cars go through. But if you think in terms of number of people, then you allowed more buses going through. Right? So you might, so the optimization is different. So it's very much the philosophy or the concept of whether you want to move more people or you want to move more cars. Because if you want to move more people, then you probably provide priority to buses, right? Because bus carries 100 people. That's a lot of cars equivalent. So if you let's say you can let one vehicle through, would you let the bus through, or would you let the car through? Or so that's the kind of decision that people need to make. So if your point is always about moving cars, then obviously you're not trying to optimize number of people you try to move. Okay, so that's although it's very subtle, but it's very important. Subtle difference, but very important. For safety, of course, if you want to measure safety, how we are performing, we need to measure about fatalities and injuries. If you don't measure this, we don't know whether the curve I showed, whether it's improving or not improving. If you look at sustainability, we need to measure air quality, noise pollution. The quality of service, we talk about travel time reliability, so we need to know whether we can get from A to B regularly at what sort of time. In terms of public transport, maybe frequency of service, on-time performance. So these are important factors. So, but in our subject here, we focus mainly on efficiency. Okay? So we don't touch on fatalities or safety or sustainability that much. So when we look at efficiency, we look at volume, throughput. If you're interested in moving vehicles, then we should be looking at vehicles per hour. If your focus is on moving people, then it should be people per hour. Right? So there's a very subtle difference. If again, more on the vehicle side, if capacity, we will measure vehicles per hour per lane that you can carry. Speed is another thing. Occupancy. The word occupancy here has very different meaning for different people. Occupancy for buses means that, or in terms of number of people, a number of occupants per vehicle, or number of occupants in the bus, number of people, meaning the number of passengers. That's one form of occupancy. For loop detectors, it has different meaning of occupancy. Right? It's a time that loop is being occupied. We will go through that. Again, measure travel time. That's another one. Origin, destination, and then the path people use. Okay, origin and destination is important because one thing in terms of transport is that we can measure the traffic volume. We have been measuring traffic volume for a long time. The good thing about traffic volume is that you know exact volume, but you don't know where they're coming from and where they're going to. Okay, so at that point, you know how many vehicles, and you can do something about it. But we don't know the whole path. We don't know where they're coming from, where they're going, and then which path that they use. Right? So if you want to change divert people for different path, we need to have this origin, destination, and path information. Those are very important. So in terms of data collection, I would classify them into two different types. One is what we call fixed sensors. So it fixed at one point. Right? So inductive loop, microwave, videos, automatic number plate recognition, ANPR, Bluetooth, Wi-Fi, RFID, they're all usually fixed at one point. I have colored the bottom half with a different color. That's because you can actually capture the ID of the objects. So for example, these two, you can capture the number plate of the cars, for example, if you're capturing them using video or number plate recognition. Bluetooth, Wi-Fi, RFID, all those tags or devices that you capture has the ID. So you can actually know, you can actually recognize that. So for example, in the inductive loop, you only know that a vehicle or an object has passed, but you don't know the ID of the vehicles, right? And then we have mobile sensors. We talk about GPS or prop cars. Prop cars are usually just like, think about a taxi with a GPS. We show the videos of them running. Or smartphones, we also have a GPS device in there. So they are mobile because if we carry our mobile phone, we move around. So that's the sensor. The sensors move around. Whereas inductive loop doesn't move. It just stays at one point. That's the difference between fixed and the mobile sensors. So if you look at the method of observation between fixed and mobile, is that you're familiar with time-space diagram? You've seen this many times? Yes? No? So this is time, this is space. Okay, so this line here is like a trajectory of a vehicle, of a person, like that. Okay? So this is, let's say, person number one, or car number one, number two, and then plus n. So this is space, right? So along this space. So think about this like a road section, if you like. The trajectory of the vehicles over time. So let's say vehicle number one starts at this point, and then it goes that way. So when you have a sensors fixed at one point, the good thing is that it can, within a time, it can count all the vehicles that passes through that point. So everything at that point is captured. Okay. Of course, you can also look another way. If you have an aerial photographs, you might have a drone these days. You can capture an aerial photograph. If you take one snapshot, you can actually count the number of vehicles within that space. So actually, this is how you calculate density, number of vehicles per kilometer, for example, right? So that's how you can fix that one point, fix in terms of the space, or fix in terms of the time. Okay. So is it one fixed location and one time. So there's also another way you can observe, which is mobile sensors. So let's think about this as us. So for example, we may be using the transport department app. No, that one. Let's say we're using a Google app, for example, right? But not every one of us are using. But let's say in this example, we are 2 persons using. But because we are moving, so we know exactly all the points let's say every seconds we collect the data. So every seconds we know this. So we are able to plot these points. So if you connect all the dots, this is your trajectory. So how you travel. So this is 2 persons having that app. You do that. Okay. So the points move along. If you look at the other one, this one, it's not. You only collect those points at one point in time, or one location, or one time. This one here, you have different points. Okay. So because you are moving, so there's a difference between fixed and a mobile. So this one, I've mentioned that. So if we, there are some other devices, which is that, I will talk about Bluetooth later. So sometimes there's some devices, either through number plate recognitions or whatever, you may be fixing at one point, but it doesn't capture everything. So even though when you have cameras, for example, sometimes cameras cannot capture all the vehicles because, or cannot read all the number plates because there's occlusion. So you might have a big bus and then you have a small cars, right? So the big bus blocks all the small cars, so you cannot capture everything. So even though this can be a camera, it doesn't capture everybody. Okay, so it captures some of that. And different points you capture different people. So when you have such a system, you can see that you don't to connect 2 points. To draw a line, you need to have 2 points. So you cannot draw lines for every one of them. Okay, so different methods collects different type of data. Some methods like loop detectors, they tend to collect a large percentage of the vehicles, almost 100% of the vehicles crossing one point. Bluetooth and Wi-Fi, for example, only collect a sample of them for other reasons. We will talk about that later. So the point is that not even though you have fixed sensors, you do not necessarily collect all the data at that point, depending on the technology that you use. Okay, I've checked this already. Quickly, the loop detectors, how it works for those one or two who might not know is that we cut a loop, cut a groove on the pavement, and then we put the loop around here. So it's a bit like your high school experiment where you have the wire and you put the magnet or metallic objects. You move around and you can see the meters go that way, right? So what happens is that when a car comes, it just triggers, it creates an inductance, so it just goes a 0 and a 1. So there's no vehicles, it's 0 and then it goes 1 like that. Okay. So from that path, we can actually capture the vehicles. So it's a bit like cutting the loop like that. It's low cost because it's cheap to do. Not highly accurate, but depending on how it's maintained, the accuracy is about 90-95%. It takes a while to install it. It's usually installed close to the road. So you can have on the freeway, for example, you can have them as a single loop. So single loop means that it doesn't look at speed, right? So it only counts number of vehicles. So in the intersections like this, you can see two. So because of these loops, you can see the loops are connected to the cabinet box, and then from there you can actually work out the algorithms. The signal timings based on those presence values. You can use the loop for access control. Because when the vehicle passes through here, there's an object. This is used especially for getting out of a parking area. Right? It's not so much for coming in because you want somebody to pay and all that kind of stuff, but to get out, you usually, if you have already paid it, you can use it. That's a way to do that. Okay, this is just some example about how it works. Remember, I talked about the 0 to 1. So when the vehicle passes through this, it gets a 1 signal, and then once it comes off, it's a 0 signal. So when the vehicles touch the edge of the loop, so it goes 1 until the end of the vehicle, the rear of the vehicle passes through that point, then it gets 0. So over a period of time, if you count the number of ones, so that becomes the number of vehicles. Okay, so this is how the loop detector works. So they count the number of ones, that becomes the number of vehicles. Now, the different speed, different vehicle length create different time, Ti, like this. Okay, so for example, if you're driving very slowly, so it will take longer time to pass. This one will be longer. Okay, so if you drive very, very fast, so this one will be shorter. Okay, so for example, if we have, let's say these we have 4 vehicles. In one situation, they drive at 100 kilometers per hour. This time here will be very small. Okay, if you have same 4 cars driving at 20 kilometers per hour, this time here will be very large, and then therefore the occupancy is greater. So occupancy is the number of time you sum up all these TIs divided by this time period. That's the occupancy. Okay, so if you're driving very fast, that means that this is very small. So your summation of this gray area is much smaller than the T. So your occupancy value is low. If it's very slow, you have bigger areas, so your summation, the occupancy is higher. So from the same 4 vehicles, from the occupancy value, you can already work out that one is slower, one is faster through the occupancy value. Okay? So same 4 vehicles just from occupancy value, you can work it out. But in operation, it's not exactly that simple, but the concept is like that. So the flow is the number of pulses that you get divided by time. So in this case, it will be 4 vehicles. Occupancy is the summation of the TIs divided by time times 100% is the occupancy. So I mentioned about two different types of occupancy. One is loop occupancy, like that. The time, the space is taken. The other occupancy is more about number of people in the vehicle. So that's the occupancy. So don't confuse the two. So if you want to calculate the speed, we need to have two loops. One is you need to have upstream and downstream loop, 2 loops to calculate speed, because just imagine a vehicle's passing through at this point. So let's say a vehicle is driving, it passed that point, so you know the time it reached here, and then the time it reached here, right? Because we know you're installing the loop, you cut the loop, you know exactly the precise location. Okay, so you know the space between here and here. Because the moment the vehicles pass through this point, you know the time, you know this time. So this time minus this time divided by the space, this will give you the speed, right? Distance over time, correct? So that gives you the speed. So that's how you work out the speed from the loop detector. Is that okay? So, once again, this is the traveling direction. So the vehicle, this is a loop. So when the vehicle touches this point, you get the pulse. Touches this point, you get another pulse. So two different pulses. So you know the time here, you know the time here. 2 times distance divided by time gives you the speed. Okay? So you need 2 loops to work out the speed, usually. So you can see in a situation like in the freeway like this, you have loops, 2 loops to work out the speed on the freeway. So once you have that, you know, you can count, you can have speed, then you can get your fundamental diagram as well. Okay, so this is just an example of the fundamental diagram collected, but over different rainfall. So this is, the blue one is when it's not raining, the yellow one is when raining, you have some rain. Right? These are observed value. I just want to cover one more and then you stop. Let me see. Okay. So these are the very old-fashioned tubes, you know, because it's easy. You just punch in some tubes. These are temporary ones for counting, but the concept is the same. The moment a vehicle squeezes the tube, it triggers it closes the thread, creates a signal. So there are 2 tubes. You can measure the speed. You can count and you can measure the speed. There are other technologies like either microwave, infrared, ultrasonic detectors. They're all the same principle. They detect the presence. So there's a footprint. A vehicle passes through that point. They know that there is an object, so they start counting the number of vehicles that way. Okay. I think I'll stop. We should stop here. We continue the camera next week. Somebody left a pen, is it? No?
Hãy subscribe cho kênh Ghiền Mì Gõ để không bỏ lỡ những video hấp dẫn.